Hello everyone, this is lesson 4.4 to 4.6, Triangle Congruence Theorems. In this lesson, you're going to learn some theorems that will help you prove that triangles are congruent. So before today, in order to prove that triangles are congruent, you would have had to prove that all three sides and all three angles are congruent by the definition of triangle congruence. However, we have some shortcuts in order to prove that two triangles are congruent. And those are these listed right here, the SSS, and S stands for side and A stands for angle. So if you know that three sides are congruent, then you know that the triangles are congruent. If you know that two sides and an angle between them are congruent, you know that they're congruent. And if HL stands for hypotenuse and leg, so that's a specific right triangle theorem. So if you know that the hypotenuse and one of the legs are congruent, then you know that the triangles are congruent. And then ASA and AAS, so combination of two angles and a side. So also AAS is the same thing as SAA. We just write it as AAS instead. So let's go ahead and talk about these. But before we do that, we do need to go over some vocabulary. So that is included sides and included angle. Included just means in between. My apologies. So when you're talking about an included angle, an included side, it's just a side that is in between two other angles. And an included angle is an angle that's between two sides. So here we're going to name the included side between the given pair of angles. So angle HGI and angle HIG. So HGI and HIG. So what would be the included side, or the side that's in between these two angles? That would be GI. Side GI is between them. So this would be ASA if you were looking at it with congruence. Okay, how about number 2? Number 2 says GHI and HIG again. So what would be the included side for those two angles? And that would be HI. Let's do GJI and IGJ. So GJI and IGJ. That would be GJ. And then finally, IJG, which is the same thing as GJI, and GIJ. That would be IJ. Here it doesn't matter if you say IJ or JI for any of these. All right, so now let's talk about the included angle. So if you're talking about side GI and HI, so GI and HI, then the included angle would be angle H. And let's just do the odds for these. So IG, HG. Go ahead and think about it. IG and HG. This would be angle HGI. And then JG, well, same thing here. JG and IG. This would be this angle here is in between the two sides. So angle JGI. All right. And then just a reminder that parts of a right triangle, the hypotenuse is on the opposite side of the right angle. And then the other two sides are called legs. There's a leg, there's a leg. And then the Pythagorean theorem is useful to us. A squared plus b squared equals c squared. So the sum of the squares of the legs equals the square of the length of the hypotenuse. Okay, if that doesn't work, then it's not a right triangle. If it does work, then it is a right triangle. Okay, so here come the abbreviations. So the first one is if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. This is called SSS. So here in this diagram, you know that KL and NL are congruent, KM and NM are congruent. So that's two sides, but what's the other side? Well, remember from some of the proofs that we've done that we can say that LM is congruent to itself by the reflexive property, so that would be the third side. So whenever they share something, then go ahead and mark it congruent in the diagram. And then next one, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So if you have two sides and the angle that's congruent is in between them, then that's SAS. So here we have BC and DA congruent, and then here the side that they share is congruent, but where is the included angle at? I don't see any angles that are marked congruent. Well, you do know that the two lines are parallel, so AC would be a transversal, and then you would have alternate interior angles. So whenever you see that the angles or that the lines are parallel, then go ahead and look for alternate interior angles. Okay, so this would be side, angle, and then side. Side, angle, side. Okay, make sure you also write down the diagrams in your notes. Okay, ASA. So this is the opposite. You have two angles and then the side in between them. So here you have angle AC, DF, and then the side that's in between those two angles is marked congruent. Whereas in the next one, AAS, the side is not in between them, it's after the angle. So AC and then side CB, DF, side FE. Okay, it would also work if the tick mark was over on this side. Okay, this would be just go the opposite way. Angle, angle, side. Angle, angle, side. Whereas up here, it's angle, side, angle. You have to kind of go around the triangle, either clockwise or counterclockwise. It doesn't matter, just however the diagram is marked. Now, if you look at these combinations, you might notice there are a couple that are missing here. So one of them that's missing, before I talk about HL, is angle, angle, angle. So if you know that all three angles of a triangle are congruent to all three angles of another triangle, it doesn't necessarily mean that they are congruent. However, they would be similar triangles. So in this case, they are the same shape, but not necessarily the same side if you don't know any of the side lengths. Okay, the other one that's missing is SSA. So SSA doesn't work, and we will see why not. And then the reason that you can remember that it doesn't work is, well, if you spelled it backwards, you're not allowed to say that in school. So SSA doesn't work, and then AAA does not work to prove triangles are congruent. With this one, you actually can possibly get an acute triangle, and then another one that is obtuse. So you can actually get two different sized triangles for that one, or shapes rather. However, if you look up in this diagram, you see side, side, angle. So it does work? Well, this is just for the case of a right triangle where you have a right angle marking and you know that the hypotenuse and one of the legs are congruent. So in this case, the special case that works is for a right triangle, and that we call HL, not SSA. So don't say SSA, say HL. Now let's say that you had a right triangle and the two legs were marked congruent rather than the hypotenuse and the leg. This would not be HL. This would just be side, angle, side. Okay, so even though it's a right triangle, it's side angle side and not HL because the hypotenuse isn't congruent. Okay, so at this point, the rest of the examples are going to be in your edge elastic assignment. However, I do want you to go to, if you look in your, actually let me make sure that my pointer's on, it is. Okay, so if you look at today's folder, so I have all these tabs up here because if you look in the Friday folder, well, I guess this would be tomorrow's folder if you're watching this on Thursday, okay, go back to Friday's folder. You have GeoGebra triangle congruence, and then you have triangle congruence theorem Quizlet. Okay, if you click on this, and you open it into a new tab, you have all of these different explorations. So I encourage you to click on each of these and spend a few minutes with them. One of them we'll look at right now is the SSA, just because we said that that wasn't possible. But that was not that it's not possible, but it might prove that a triangle is acute or obtuse. Okay, so here's the triangle that's set. Here's the one we have a side, and then this, I believe it's this angle here, this 33 that we know for sure. So let me click on this. Yes. Okay, so this 84, we are allowed to change that. So I can make a change this way and that way. Okay, so one of the ways, let's see, if I extend this out, maybe went out too far. All right, it's kind of hard to get it exactly the right way. Okay, there we go. So that's close enough. So this does make a congruent triangle because you see 14 and 14 and all of the angles are pretty much the same. They're like one off, but that's okay. And then there's a different way you can do this though. So let me see here. What if we made it like this? Okay, so those connect, but is that congruent to that one? No, definitely not. This one is smaller, and this would be an obtuse triangle, 124. So in this case, we SSA does not guarantee triangles are congruent. Okay, so go ahead and click on, spend a few minutes clicking on the rest of them, and just double checking for yourself that these theorems actually do work. Okay, so an AA, that is for similarity, so that's not really going to work for congruence. And then the other thing in there was something that I definitely want you to do. So I would like you to click on the triangle congruence theorem Quizlet, and I would like you to go through this Quizlet at least twice. And what you're going to do is, it's going to give you a diagram, congruence, and how. And then you're going to figure out which one it would be, which of the combinations, or if it actually is congruent or not. Okay, so go through that at least 2 times, preferably 3 times, or about 20 minutes. Okay, so that is also part of your homework. So in your study hall or essay the next 2 days, make sure you do this. Or if you don't have one of those, then do this at home. All right, so that is the end of this lesson. I hope you have a great day.